Okay, we are now in chapter 11 in chemistry, and this chapter is the modern atomic theory. Alright, the first thing we want to look at is just a little reminder of people who have figured out the structure of the atom. So one of the more famous people was Rutherford, and if you remember, he discovered the nucleus with the gold foil experiment. And at the time, he had created the best idea for the structure of the atom. The problem is he did not answer the arrangement of electrons and their behavior. So that's what this chapter is all about. We are focusing mainly on the electron. And what we're first going to take a look at is the need to look at the energy and the light in terms of understanding electron behavior. And if you had physical science, this might sound familiar. A light can act as a wave, and if you remember, waves have a frequency and they have a wavelength. And frequency is how many waves pass a certain point in a given period of time. It's how frequent it passes, right? Okay, and wavelength is the distance between two peaks of waves. So I'd like to show you what this looks like. Okay, so there you have several waves. And wavelength, if you look at the top or the peak of two waves, and you connect them, that is the distance between two peaks of the wave. So that is called wavelength. It gets the funky Greek letter. Now frequency, if you look at the waves that I drew, this is a pretty long wave. So if you had waves that look like this, that's a high frequency. But the waves that I drew here, this has a low frequency. Okay, there are mathematical formulas that go along with this. We will not be covering that in this chapter. We're going to focus more on the electron itself. All right. The next thing we want to look at is the electromagnetic spectrum. Light is a part of the spectrum, but I'd like to show you the other parts of the spectrum because a lot of them are involved in your everyday life. Okay, so this spectrum goes from high frequency wavelengths to low frequency wavelengths. Okay, the higher the frequency, the more dangerous they are. So the first type of energy I'd like you to see is called gamma. So this is in a nuclear weapon. That's the energy given off. That's also the energy in cancer treatments. That's why it also makes people sick. That's why they lose their hair. They cannot eat because this is radiation that is supposed to affect the cancer cells, and yet it will also go after healthy cells as well. So that's why people get sick. Next in line is the X-ray. And yes, people have X-rays. So once or twice a year for a medical procedure is fine. But if you notice, even when you go to the dentist, they will put a lead vest on you and then step out of the room. That is because the dentist will be giving X-rays all day, and if he or she is around that radiation, it could make them sick, so they need to protect themselves. Okay. Next in line is UV, and this is also known as ultraviolet. Okay. So this is what affects your skin when you go out tanning. It's what causes the color change. But you are essentially burning your DNA, and that is the color change that you see. So this is the radiation coming from the sun. Okay, the part that you're going to look at is light or visible. And this is what's going to allow you to see the rainbow. So we will be doing a demo and a lab that does involve seeing the different colors that are part of visible light. And I will show you those colors in just a little bit. Okay, next we have IR. This is called infrared. And two areas that you might recognize this are night vision goggles, or those lights that keep buffet food warm. So that's the kind of heat lamp that you see. It's usually red, right? So that's infrared. Okay, next we have the microwave. And you should note that microwaves really do not heat your food, they are speeding up the particles of your food, so that's an increase in temperature, right? We learned that in the last chapter. So the faster something moves, the higher the temperature. So that's what the microwaves are doing. And then finally at the end, we have things like radio, TV, and the cell phone. Okay, you can tell these are lower frequency. We use these more often than we would say in X-ray. So that's why they're at the low frequency end of the spectrum. And just keep in mind that there is some discussion of cell phones maybe causing some damage in our brains. I know Sheryl Crow had brain cancer, and she was thinking that maybe her use of the cell phone had something to do with it, but I haven't really taken a look at a lot of the research on that, but it has been talked about. That's probably because the phone is so close to your head compared to the TV or the radio. All right. Now, electrons. Okay, more about the electrons. Okay, so we know they're part of the atom, right? Now, atoms themselves will release energy. And they release this energy by emitting visible light in certain wavelengths or colors. And the part of the atom that's doing this is that outer part, which is the electron. Now, you're going to do a lab that's called a flame test, and that's where all this is heading to. So if you have a flame, right? Okay, and if you stick a certain chemical in that flame, what's going to happen is the atoms are going to become excited. Okay, so just think about it. They're put in something hot, it's going to make them react, right? So they're going to become excited, and then what's going to happen is they will release energy and move to a lower energy state. And when they do this, that's when you see the color. So you're going to be sticking some solutions into a flame, okay? The atoms in that solution will become excited, energy is released as light, the energy goes down to a lower state, and you see that as color. So it's a pretty interesting lab. All right, and the last thing I'd like to leave you with is the rainbow. Okay, I'd like you to know the different colors that exist, which you probably know, but it's also important to know which has the shorter versus the longer wavelengths. So if I ask you the rainbow, maybe Roy G. Biv comes to mind, and that's exactly what I'm talking about. So there's Roy, there's G, and there's Biv. Okay, so do you remember the colors? Okay, red, orange, yellow, green, blue, indigo, which is a dark bluish purple, and violet. Okay, and now you have red through violet, and in your lab you will discover which has the different types of energy. So I'm going to leave it here, and we'll discuss more about this when you are done with your lab.